Robotic challenge. Problem statement. Construct an all-terrain robot capable of traveling over various rough surfaces, and which can ascend and descend a staircase, and then compare its performance to a robot using regular wheels. Hotpot. A solution. Steps to solve the challenge are: Design challenge, Build challenge, Programming challenge, Working. Design challenge. Hotpot is designed to operate on all terrains. It can drive on any indoor surfaces and most outdoor surfaces. As our bot should be an all-terrain bot, we will have challenges in choosing the mechanism and movement to complete the task. We have designed special shaped wheels made out of acrylic which helps the bot to perform various terrains. You can also make the wheels with other hard materials like carton box, etc. The mechanism of the bot is specialized by mounting the motors in different pattern. Now let's start to build the bot. programming challenge. Let us now start programming our bot. The program which we will be coding is the same RC bot program. Either you can choose to program it on your own or continue to watch this video to learn on how to program. Let us see how to control our bot using the TV remote.
How this basically works is that the TV remote sends a particular data every time a button is pressed on the remote. First, we need to check what data is sent from the TV remote when a command is given, that is, when a button is pressed by the user. For that, we use a set IR port and get IR port blocks from the communication section. The set IR port is used for defining the pin number of the TV remote receiver on the Tinkeroid. As we can see from the Tinkeroid pin table, the IR remote receiver is connected to pin number 26. So, we define it as 26 in here. The get IR code blocks tells the IR remote receiver to receive the data sent by the TV remote if there is any, and save it in the IR code block. We need to store the received data in a variable. Here the received data being a string, we use a set string variable. The variable name is user defined. Here we name it as received data. Now to see the received data, let's print it on the serial monitor using serial print block. We will add a small delay to make sure data is visible now. Upload the program and save it. Make sure that the Tinkeroid is connected to the PC and the COM ports are selected before uploading. Once uploading is done, go back to Audio block and open serial monitor. Now you can see that when I press the forward button on the remote, the data being received by the Tinkeroid is 20 and 820. Here we receive two unique data for every button that is being pressed on the remote. Similarly, for backwards, we receive 21 and 821, and for right we receive 10 and 810, and for left we receive 11 and 811, and finally for stop, that is the middle button, we receive 3B and 83B. As we know what data are being sent from the TV remote for each command. Based on the data received, let's program the bot to move in the respective direction. Let's initialize the data so that they can be compared with the received data. For that, we use set string variable and rename the variable as forward. We know that for forward we receive two data, that is 20 and 820. Since a variable can store only one data at a time, here we use two variables for initializing 20 and 820. We name the first as forward and the second one as forward 1, and load the values with 20 and 820 respectively. We repeat the same procedure for the rest of the directions. That is, for backward, we load the value 21, and for backward one we load the value 821. Similarly, for left we load the value 11. For left one we load the value 811. Now for right the value is 10. For right one the value is 810. And finally for stop the value is 3V. And for stop 1 the value is 83V. In this Tinkeroid, all the 4 motor ports are programmed to move in the forward direction. When we connect the motor to any one of the ports in the left side and switch the battery on, it moves in the forward direction. Similarly, when we connect the motor to any one of the ports on the right side and switch on the battery, it moves in the reverse direction, though the motor is programmed to move forward. This is due to the flipping of the motor from left to right. So, in the program for the right side of the motor, we reverse the logic. As earlier, we use set IR port and get IR code from the communication section. And name the pin number as 26 as defined earlier. The get IR code is used to receive the data. We store the received data in the variable, so we use set string variable. The variable name is user defined and we name it as received data. Now we compare the received data with the initialized characters. For this we use a if block. In the test section we compare the received data with forward and forward 1. This is because, as we saw earlier, each button sends 2 unique data. So, we must compare it with both the data. That is, if the received data is equal to forward or forward 1. We use a OR block for this purpose. If the received data is equal to forward, then the bot must move in the forward direction. For this, all the motor ports must be assigned with forward direction. We know that the right ports 3 and 4 have to be given reverse logic. We set them to backwards. Similarly, we compare the received data with the backward. If the condition is met, then the bot must move in the backward direction. For this, all the motor ports must be assigned reverse direction, that is motor port 1, 2, 3 and 4. We know that right ports 3 and 4 have to be given reverse logic, so we set them to forward. Next, we compare the received data with the write. For this, the left motors 1 and 2 must be given forward direction and the right motors 3 and 4 must be given reverse. We know that right ports 3 and 4 have to be given reverse logic, so we set them to forward. Now we compare the received data with the left. For this, the left motors 1 and 2 must be given reverse and the right motors 3 and 4 must be given forward. We know that right ports 3 and 4 have to be given reverse logic. We set them to backward. And finally, for stop, we compare the received data with the stop. If the condition is true, then the bot must stop. For this, all the motor ports 1, 2, 3 and 4 must be given release. Now we will have a recap on the program. First we initialize the received data. Then we set the IR port and store the received data in a variable called received data. Then we compare the received data with the motor directions and make the bot to move in the respective direction.
Working.